Good morning, dear students. I am Dr. Srinivas Bhattani, Professor of Chemistry in Sri Academy, Hyderabad. So, in the last video, we have seen the reaction intermediates. The first one is the carbocation. Today, we are going to discuss about the carbanion. The second one is the carbanion. Carbanion. The second intermediate is the carbanion. What is meant by carbanion? An organometallic compound. Organometallic compound means organic compounds attached with the metal. An organic compound is a compound contained between carbon atom and metal atom. Carbon atom and metal atom. If a bond between carbon atom and more electronegative atom, the electrons are closer to the carbon. It looks like ionic bond. The carbon becomes a negative ion, is known as carbanion, and metal atom becomes positive ion. That is, see here, carbon, metal. Metal becomes more positive, more active metals, and carbon is negative. So this is called the carbon. The bond between the carbon and metal. The bond between the carbon and metal. So we have to see the examples we can understand. For example, methyl lithium or alkyl lithium. Alkyl lithium. This is the alkyl group. Alkyl means the carbon containing. This is the hydrogens, okay, and lithium. So here, lithium is a positive sign, and carbon is a negative, partially negative. And another one, when this react with the another methyl. Another methyl, for example, another methyl, iodine, mean halogen, methyl halide. When both are react, so what happened? Mean this one exchanged this compound. Mean methyl lithium form and methyl chloride formation takes place. So this will happen. This will happen. So mean the methyl lithium exchange the group, mean more active metal. So this is a carbanion. The carbanion. Mean here, so we can understand the structure, how the structure formation takes place. The structure is important. So structure mean here that, for example, the 3 is hydrogen or either hydrogen or alkyl group. For example, so simply you have to write the R. R is hydrogen or alkyl group, anyone. So you can take here R. R. And an end this low. This is the carbanion structure. The structure of carbanion mean every carbanion possesses one unshared pair electrons, and three pairs of bonding electrons around the central carbon atom. which is sp3 hybridized. The total number of electrons are 8 around per carbon ion. So this is the structure of carbon ion. Mean how to form the carbon ions. The carbon ion formation is important. The carbon ion formation is important. Metal and carbon. The bond between the metal and carbon. So formation. See formation. Formation. The heterocyclic fission of this covalent bond forms carbon ion. Heterocyclic fission. From compounds such as nitro, cyano, carbonyl groups, mean heterocyclic compounds. Cyano is heterocyclic, nitrogen is there. Nitro, it is also heterocyclic compound. Carbonyl group, CO, it is also heterocyclic compounds. From this, we can form the different types of carbon ion compounds. For example, methyl cyanide. We can take methyl cyanide. This is the methyl cyanide. Just you remove one hydrogen from here. One hydrogen. So what happened? CH2 and C3 will bond N. So this is what? This is the carbon ion. But this one, this either this formation or this formation, means CH2 is the negative. So this is the cyanide. And in the case of carbonyl compounds, for example, CH3, C double bond means acetaldehyde. So when we remove one hydrogen from methyl here, acetaldehyde, we will get the, so this one is the carbocation. Or we can write CH2 double bond, this one, this will formation takes place. Okay, so this compound, either this one or this one. So this is the formation of carbon ion. Formation of carbon ion. When nucleophiles add to a carbon bond. So what happened? Nucleophiles add to carbon. Nucleophiles mean, for example, ethoxy compound add to the ethyl means cyano compound. So example we have to see. So ethoxy compound. Another formation, the second formation, when that here we can take the ethoxy compound. This is the ethoxy compound. So mean this remove the oxygen. So only here. So this one ethoxide, we can say ethoxide. When react with nitrile mean cyano compound mean CH2 double bond C triple bond N. This compound we can react with this one. So C triple bond hai CH. So what happened here? Here this bond will come, this double bond will come this side, this double bond will come this side, and immediately this one will come to this side. So what will formation takes place here? So C2H5 O bond CH, 2 bond CH, double bond C, bond N. This bond formation takes place. Otherwise, see here, so we can put here, so what happened? We have double bond, 1, 2. So like this formation. So this is a carbon. This is the 1, 2, 3, and 4. This is the carbanion formation from where? So when ethoxide react with the nucleophiles. So when nucleophiles add to carbon bond formation, carbon. So that is the formation of the one more compound. Okay. So what are the factors? The factors are important. The factors mean stability of carbanion is favored by more electronegative carbon. For example, so more electronegative atom carbon so the order is important for the competitive exam. The stability of carbanion increase with increasing electronegativity of carbon. Increase of the electronegativity of carbon. For example, CH3, CH2, this is the carbanion, is less than the CH2 double bond CH. Is less than the CH double bond. So this is the order for single bond, double bond, triple bond. Mean the stability of carbanion increases with increasing electronegativity of the carbon. This is one. So it will favor that one. And the effect, one more factor, that is the plus I effect. Plus I, the stability of alkyl carbanion decrease with the increasing of plus I effect. So what? Please note down. Say that methyl increasing the plus I effect, increasing the plus I effect. So here methyl carbanion is greater than the CH3 and CH2. So this carbon, ethyl carbanion, and is greater than the this one. Is greater than the tertiary. You can take the tertiary. This carbon. So this is about the increasing the stability of alkyl carbanion decreases when increasing the plus I effect. Increasing the methyl groups, the plus I effect is increasing. So what happened? Decreases the carbanion, the stability carbanion. Though this is very, very important. And one hyperconjugation, reverse hyperconjugation, or minus R effect, resonance effect. Reverse hyperconjugation or resonance effect increase the number of benzene rings, increasing the stability. So let's look at some important orders. So please note down. Orders, we can see for example, order of the negative compounds. Some compounds I will give you, you have to find it. So for example, here are the compound CH2, this is the carbanion, this is the carbanion. In the case of methyl, in the case of orthomethyl and metamethyl, meta position and para position. So three position are the matter. What is the order here? Order. The order is important. Which one is the more stability compound? So definitely we know that the more stable compound is the meta position. Meta is greater than the para, greater than the ortho. So here for example A, B, C. So what happened here? Meta position is a greater. So B is greater than the C is greater than the A. This is simply methyl or alkyl group. In the case of methoxy group, in the case of methoxy group, CH3, methoxy. So orthomethoxy, metamethoxy and paramethoxy. So what is the order? Please see the order. Here, see, definitely same order but little bit change. B is same, meta is greater than, But here, A is greater than the C, So this is order in the case of methoxy. In the case of nitro, what happened? Nitro. In the case of nitro, metanitro, orthonitro, and paranitro. So how? What is the order? The order is simply A is the order of stability. Order is A is greater than the C is greater than the B. So B is the last. So mean A is the greater stability than the C. Mean orthonitro is greater than the paranitro is greater than the metanitro. That is in the case of a nitro compound. Nitro, orthonitro. Mean nitro, orthonitro, metanitro and paranitro. So these are very, very important. So this is for methyl. Methyl order, stability of methyl and stability of methoxy and stability of nitro compound. Nitro. The order is very, very important for the competitive exams. Okay? So on benzene ring. So these are the very, very important for carbon ions. So in the next class we will see the free radicals. Okay, so today what we have some of the stability of orthonitro, benzene ring containing the orthonitro, methoxy, methyl groups. So order we know, and the stability of alkyl carbon ion decrease with increasing the plus I effect, inductive effect. That is increasing the inductive effect. Inductivity means increasing the methyl groups. That is also. And more electronegativity carbon mean that single bond, double bond and triple bond containing the negative groups mean the double CH3CH2 negative mean ethyl carbon ion is greater than the ethylene carbon ion is less than the ethane carbon ion. Ethane carbon ion is less than the ethylene carbon ion is less than the ethane carbon ion. So that is the factors. The factors are important for the competitive exams. Okay, thank you very much.